Let me be direct with you from the outset, because what we are witnessing is not a conventional arms race. It is not a diplomatic breakthrough. It is not even a traditional military alliance forming in real time. What we are witnessing is the quiet redistribution of technological supremacy happening right now, with consequences that will reshape global power for the next 3 decades. And most people do not even realize it is happening. I am looking at a technical specification document that has been circulating among defense analysts in Beijing, Moscow, and Tehran for the past 96 hours. What it describes is not an aircraft carrier. It is not a hypersonic missile system. It is not a satellite network or a drone swarm. What it describes is a semiconductor fabrication process transferred from China to Iran that allows the production of military-grade microchips at the 7 nanometer node. 7 nanometers. To put that in perspective, that is the same fabrication capability that powers advanced American F-35 avionics, Patriot missile guidance systems, and next-generation electronic warfare platforms. And as of March 2026, Iran now possesses that capability independently. In the next 20 minutes, I am going to walk you through exactly why this technology transfer represents the single most significant shift in Middle Eastern military balance since the Islamic Revolution, why American sanctions infrastructure has fundamentally failed to prevent this outcome, and why your government has been deliberately quiet about the implications. This is the analysis you are not getting from mainstream sources. Subscribe now if you have not already, because what we are about to cover is being actively discussed in closed-door sessions at the Pentagon, and the conclusions are deeply uncomfortable for Western policymakers. Let's start with the fundamentals of semiconductor technology, because understanding what just changed requires understanding what these components actually do. Modern military systems are not mechanical. They are computational. Every missile guidance system, every radar array, every electronic countermeasure, every command and control network depends entirely on microprocessors. The smaller the transistor node, measured in nanometers, the more powerful and efficient the chip. American military systems currently operate on chips fabricated between 5 and 7 nanometers. Russian systems operate mostly at 14 to 28 nanometers. Chinese cutting-edge military chips are at 7 nanometers. And until 4 months ago, Iranian military electronics were stuck at 45 to 90 nanometers, roughly equivalent to consumer technology from 2010. That gap mattered enormously. It meant Iranian air defense systems were slower to process threats. It meant their missiles were less accurate at terminal guidance phase. It meant their electronic warfare capabilities could be jammed more easily by American systems. It meant, functionally, that Iran's military was fighting a 21st century war with partially 21st century tools and partially 2010-era computational power. That asymmetry is what American planners relied upon when modeling conflict scenarios in the Persian Gulf. According to reporting by the South China Morning Post, confirmed by semiconductor supply chain analysts at Tech Insights, and corroborated by Israeli intelligence assessments shared with the Biden administration in February, China's Semiconductor Manufacturing International Corporation, known as SAMIC, has transferred complete fabrication blueprints, lithography techniques, and material science specifications to Iran's Electronics Industries Organization. This is not a sale of finished chips. This is a transfer of the capability to manufacture chips independently. The difference is existential. Subscribe if you are watching this and realizing you are not getting this level of analysis anywhere else. Now, let us talk about what Iran actually built with this knowledge. Announcement number 1, the semiconductor fabrication facility in Isfahan. And this one matters more than anything else because it represents technological sovereignty in the most critical domain of modern warfare. The facility is located approximately 12 kilometers southeast of Isfahan's city center, embedded within the existing defense industrial complex that has been operating since the 1980s. Satellite imagery, analyzed by ImageSat International, shows a new cleanroom facility measuring roughly 18,000 square meters, completed in November 2025. That is large enough to house multiple fabrication lines. The construction timeline was aggressive. Ground was broken in April 2025. Full structural completion occurred in 7 months. Equipment installation began in December. And according to signals intelligence referenced in a recent report by Defense Security Asia, the facility achieved initial production capability in February 2026. Commander Liu Xiaoming, a researcher at China's Academy of Military Sciences, has described Iran's new capability as, and I am quoting him directly here, sufficient to indigenize guidance systems, radar processors, and communications encryption modules without reliance on foreign supply chains. That is the ball game. Iran no longer needs to smuggle chips through shell companies in Dubai. It no longer needs to rely on black market semiconductor supplies from Malaysia or Turkey. It can produce its own. The facility currently operates 2 fabrication lines. The first line produces chips at 14 nanometers, which is immediately useful for upgrading existing missile systems and radar platforms. The second line, still in calibration phase, is designed for 7 nanometer production. Initial yield rates are estimated at 60 to 70%, which is acceptable for military applications where cost is less constrained than in consumer electronics. Iran's defense ministry has publicly acknowledged the existence of advanced domestic electronics production, but has not specified the nanometer node capability. That silence is deliberate. Received. That is announcement number 1. Announcement number 2, the supply chain that made this possible. This is the part Western intelligence agencies have confirmed but have not publicized because acknowledging it would require admitting that sanctions enforcement has comprehensively failed. China did not simply hand over blueprints. It provided the entire ecosystem, extreme ultraviolet lithography equipment, which is essential for sub-10 nanometer production, was supplied through front companies registered in Hong Kong and Shenzhen. Chemical precursors for photoresist materials were shipped via Pakistan, labeled as industrial solvents. Precision measurement tools came through Russian intermediaries. Training was conducted in 2 phases. Iranian engineers, approximately 40 individuals, spent 6 months at SMIC facilities in Shanghai and Tianjin, learning fabrication processes. Then, Chinese technicians, at least 15 specialists, spent 3 months in Isfahan during equipment installation and initial production runs. This network was not hidden. It was simply too distributed and too technically complex for sanctions enforcement mechanisms to interdict. The U.S. Treasury Department's Office of Foreign Assets Control tracks financial transactions. It does not track shipments of dielectric materials or vacuum chamber components because those items have legitimate civilian uses and blocking them would cripple global semiconductor supply chains. Stay with me because this is where the narrative completely changes and where the implications become impossible to ignore. The semiconductor transfer is not happening in isolation. It is happening simultaneously with 3 other critical technology transfers that together represent a systematic effort to create a technologically self-sufficient Iranian defense industrial base. Announcement number 3, and this one almost nobody in the mainstream media is connecting correctly. Missile propulsion technology from North Korea, advanced radar algorithms from Russia, and satellite data sharing agreements with China are all being integrated into systems that will now be powered by domestically produced Iranian chips. In January 2026, North Korean engineers visited Iran's Seyed Mohammad Industrial Group, which develops ballistic missiles. According to South Korean intelligence assessments shared with the Wall Street Journal, those engineers brought solid rocket motor designs that improve thrust-to-weight ratios by 18% compared to Iran's existing Sejil-2 missile motors. Higher thrust means longer range, heavier payloads, or both. Those missiles will now use Iranian-manufactured guidance chips instead of smuggled foreign components. Russia, in exchange for Iranian drones used in Ukraine, has provided synthetic aperture radar algorithms that allow much higher resolution targeting at longer ranges. Specifically, algorithms that enable target discrimination between armored vehicles at distances exceeding 30 kilometers. Those algorithms require significant computational power to run in real time. 7-nanometer chips provide that power. 14-nanometer chips do not, at least not efficiently enough for mobile missile launchers. China has granted Iran access to Yaogan reconnaissance satellite data, which provides optical and radar imagery of the Middle East at resolutions sufficient for target identification. That data feeds directly into missile targeting systems. And those targeting systems now run on chips that Iran controls from raw silicon to finished processor. The reason Iran's missile threat is escalating is the same reason its air defense capabilities are becoming far more credible. Computational power. The Bavar 373 air defense system, Iran's equivalent to Russia's S-300, was limited by slow target processing speeds. Upgrades using 7-nanometer chips reduce engagement cycle time by 40% according to simulations published by Iranian defense researchers in the Journal of Defense Science and Technology. 40% faster means more targets engaged per minute, which means higher survival rates against saturation attacks. Received. That is announcement number 3. Now, let us talk about what is really happening behind the headlines, because there are 2 stories playing out simultaneously, and the mainstream media is only covering one of them. The story you are hearing is about diplomatic efforts to revive the Iran nuclear deal, or to establish new frameworks for limiting Iran's nuclear program. The Biden administration, and now potentially a future administration, continues to pursue negotiations. European powers continue to express concern. The International Atomic Energy Agency continues to issue reports about Iran's uranium enrichment levels. All of that is real. All of that is happening. But here is what is not being discussed in those diplomatic circles. While negotiations focus on limiting Iran's nuclear program, Iran is achieving strategic deterrence through conventional means that are, in some scenarios, more immediately useful than nuclear weapons. A nuclear weapon is a weapon of last resort. It carries massive political costs and guarantees international isolation. Advanced conventional missiles with precision guidance powered by sophisticated domestically produced chips can be used in limited strikes, proxy conflicts, and gray zone operations without crossing the nuclear threshold. Think carefully about what this represents. When the United States imposes sanctions to prevent Iran from acquiring advanced technology, and those sanctions fail because a peer competitor transfers the technology directly, that is not a sanctions evasion story. That is not a loophole. That is a verdict on the limits of American economic coercion in a multipolar world. The Trump administration responded to Iran's growing capabilities by increasing military deployments to the Gulf and threatening maximum pressure to 0. This has not notably changed Iran's trajectory. The Biden administration responded by attempting to de-escalate and negotiate. This has not changed Iran's trajectory either, because Iran's trajectory is no longer determined by what Washington permits or forbids. It is determined by what Beijing enables and what Tehran builds. If you are an American taxpayer funding a defense budget of over $900 billion annually, what is happening in Isfahan is not a foreign policy story. It is a return on investment story. Because the entire premise of American military supremacy in the Middle East has been technological overmatch. When that overmatch narrows or disappears, the cost of military operations rises exponentially and the probability of mission success falls. These effects are showing up in Pentagon war game simulations, according to reporting by Breaking Defense. Scenarios involving strikes on Iranian nuclear facilities, which previously showed high confidence of success with acceptable losses, now show significantly higher attrition rates for American aircraft and much lower confidence in mission completion. The variable that changed between 2023 simulations and 2026 simulations is Iranian air defense computational capability. This pattern has repeated throughout history, and every time it repeats, the outcome is the same. Consider the Peloponnesian War, the conflict between Athens and Sparta that lasted 27 years, from 431 to 404 BC. Athens was a naval power with technological and financial advantages. Sparta was a land power with military discipline but less wealth. They fought each other to mutual exhaustion. Neither side won decisively. And who emerged as the dominant power in Greece after the war? Thebes and later Macedon under Philip II. The two great powers destroyed each other's capacity for hegemony, and a third actor, one that had stayed out of the prolonged conflict, stepped into the vacuum. The parallel is exact. The United States and Iran have been engaged in a 47-year confrontation since the Islamic Revolution in 1979. Sanctions, proxy wars, assassinations, cyber attacks, naval standoffs, economic pressure. Both sides have expended enormous resources. Neither side has achieved decisive victory. And who is rising as the dominant power in the Middle East and Central Asia? China. And not through military confrontation, through technology transfer, infrastructure investment, energy partnerships, and diplomatic engagement. China transferred semiconductor technology to Iran. China buys 90% of Iranian oil exports, according to data from Kpler and Vortexa Analytics, providing the revenue stream that funds Iran's defense industrial base. China built Pakistan's nuclear infrastructure decades ago and now mediates between Pakistan and Iran. China operates the port at Gwadar in Pakistan, 40 kilometers from the Iranian border, positioning itself as the economic hub of the region. The United States exhausts itself trying to contain Iran. Iran exhausts itself resisting American pressure. And China builds the infrastructure, supplies the technology, and establishes the relationships that will define the region for the next 50 years. So, where does this leave us? Let me give you three clear paths, because there is no honest middle ground here. Path 1, technological containment escalates. The United States, recognizing that semiconductor transfers have changed the strategic equation, attempts to cut off China's ability to supply Iran with any advanced technology. This would require secondary sanctions on Chinese firms, which would trigger massive economic retaliation from Beijing, potentially including restrictions on rare earth exports or dumping of U.S. Treasury holdings. The cost of this path is a comprehensive breakdown in U.S.-China economic relations, which represents roughly $700 billion in annual bilateral trade. The probability of success in actually stopping technology flows is low because China has demonstrated it can operate through intermediaries and shell companies that are nearly impossible to track comprehensively. I assess this path as politically difficult and strategically ineffective. Path 2, accommodation and deterrence balance. The United States accepts that Iran will have advanced conventional capabilities and shifts strategy toward credible deterrence rather than technological denial. This means maintaining overwhelming strike capacity, hardening regional partner defenses, and establishing clear red lines with credible enforcement mechanisms. It also means accepting that military options against Iran are now more costly and less certain, which reduces the range of scenarios where military force is a viable policy tool. This path is intellectually honest but politically unpalatable because it requires admitting that 47 years of containment policy has not prevented Iran from achieving a degree of strategic autonomy. Path 3, proxy escalation. Unable to strike Iran directly without unacceptable costs and unwilling to accommodate Iranian capabilities, the United States increases support for regional actors, Israel and Saudi Arabia primarily, to conduct operations that degrade Iranian capabilities through sabotage, targeted strikes, and covert action. Iran responds by increasing support for Hezbollah, the Houthis, and Shia militias in Iraq. The result is a region-wide escalation of proxy conflicts with higher intensity, longer duration, and greater risk of accidental direct confrontation between U.S. and Iranian forces. I think we are closer to Path 3 than the headlines suggest. The semiconductor facility in Isfahan is now a known target. Israeli defense officials have publicly discussed options for striking Iranian nuclear and military infrastructure. The technical challenge of striking a hardened underground facility is significant, but not insurmountable. Iran knows this. China knows this. And that creates enormous pressure on Iran to disperse its fabrication capability, to harden its facilities further, and to develop retaliatory options that make any strike unacceptably costly. But here is the variable nobody is accounting for adequately. Once Iran demonstrates that it can produce 7-nanometer chips reliably, it can export that capability. Hezbollah command and control systems could run on Iranian chips. Houthi anti-ship missiles could run on Iranian chips. Iraqi militias could receive Iranian-made encrypted communication devices that are far harder for American signals intelligence to intercept. The technology transfer from China to Iran is a one-time event. The proliferation from Iran to non-state actors and regional proxies is ongoing and geometrically expanding. Here are the questions I want you to take away. First, can the United States credibly prevent technology transfers between peer competitors without decoupling economically from those competitors entirely? Second, if technological overmatch was the foundation of American military strategy in the Middle East, what replaces that foundation when overmatch erodes? Third, in a multipolar world where China, Russia, and regional powers actively cooperate to undermine American technological denial efforts, what does containment policy even mean? Tell me in the comments what you think the most likely path forward is. Tell me if you believe sanctions can be effective when peer competitors are willing to systematically violate them. Tell me what indicators you are watching to understand where this situation is heading. We will keep tracking every development in Isfahan, Beijing, and Washington. That is what this channel does every single day. Subscribe now. Share this analysis with everyone in your network who is trying to understand why the balance of power is shifting in ways that most media outlets are not explaining. Turn on notifications so you do not miss the next update. Because what is happening in Isfahan is not the end of the story. It is the beginning of a much larger transformation in how power is distributed, how technology shapes conflict, and how secondary powers achieve strategic autonomy despite the opposition of superpowers. We will see you in the next analysis.